In the vast silence of the universe, there are moments when a single change can reshape an entire world. Imagine waking up one day to a planet slowly losing its warmth, where oceans begin to still and the wind carries no rain. This is not a story of sudden destruction, but of gradual quiet, of time stretching as Earth drifts into cold. In this documentary, we will explore a scientific possibility, calmly, slowly, and without fear. A journey through ice, through silence, and through the fragile balance that allows life to exist. Let us begin, not with chaos, but with stillness. The Earth is not a static world. It is a delicate system, balanced between heat and cold, motion and stillness. To understand what happens when Earth freezes, we must first understand how it stays warm. Our planet receives energy from a single source, the sun. This energy travels across space, warming the oceans, the land, and the air above us. But warmth alone is not enough. Earth holds this heat through its atmosphere, a thin layer of gases acting like a blanket, slowing the escape of warmth back into space. Now imagine this balance begins to change, not suddenly, not violently, but slowly, almost silently. The sun's energy weakens, or the atmosphere grows thinner, or both, over thousands or even millions of years. Temperatures begin to fall, first by fractions of a degree, barely noticeable, yet deeply consequential. Winters last longer, summers grow shorter. Snow that once melted now lingers. At first, the oceans resist the cold. Water stores heat efficiently, acting as Earth's final defense. But even oceans have limits. Ice begins forming at the poles, then slowly creeps outward, reflecting sunlight back into space instead of absorbing it. This reflection accelerates the cooling. A feedback loop begins. More ice, less heat. More ice still. Glaciers advance. Continents harden under white silence. Rivers slow, then stop. Life does not vanish instantly. Plants struggle. Animals migrate. Ecosystems compress toward the equator, seeking the last remaining warmth. But the cold continues, patient, inevitable. The planet is changing, not with sound, but with stillness. At first, the change is subtle, so subtle that life on Earth does not immediately realize what is happening. The sun still rises, oceans still move, cities continue to glow at night. But something fundamental has shifted. Global temperatures begin to fall, not by degrees, but by fractions of degrees. Tiny changes that seem harmless. Yet in planetary systems, small shifts create irreversible consequences. Polar ice caps begin to expand. Seasonal snow no longer melts completely. Each year, more white remains behind. The Earth's albedo, the amount of sunlight reflected back into space, increases. More ice means more reflection. More reflection means less absorbed heat. And the cooling accelerates. Atmospheric circulation patterns begin to collapse. Jet streams weaken. Weather systems lose their balance. Rain becomes rare. Snow becomes permanent. Oceans, once massive reservoirs of stored heat, begin to lose their warmth. Surface waters cool first, then slowly, the cold sinks deeper. Thermohaline circulation, the global ocean conveyor belt, starts to fail. Without warm currents, entire regions freeze rapidly. Northern continents fall silent under kilometers of ice. Forests snap and shatter beneath the weight of frost. Rivers freeze solid from surface to bedrock. Human infrastructure was never designed for this. Power grids fail. Fuel thickens and becomes unusable. Machines seize. Cities turn into frozen monuments. The oceans resist longer. Salt lowers the freezing point, but resistance is not immunity. Sea ice spreads outward from the poles like a slow, unstoppable tide. Storms vanish, not because the planet is calm, but because the energy that creates storms no longer exists. The sky clears. The air becomes dry, sharp, and painfully cold. Carbon dioxide begins to disappear from the atmosphere, not destroyed, but locked away. Frozen oceans absorb it. Snow traps it. Chemical reactions slow to near zero. Plants struggle first. Photosynthesis weakens. Growth stops. Forests die standing. Animals migrate, then stop. Life retreats underground, into caves, into soil, into darkness. The planet is still alive, but barely breathing. From space, Earth no longer looks blue. It becomes white, brilliant, silent, a frozen world drifting through the void. And the process is not finished yet, because the cold has only reached the surface. As the planet continues to cool, Earth passes beyond recovery. Not because something breaks, but because every stabilizing system has reached its limit. Ice no longer behaves as a phase. It becomes structure. It defines the surface, the climate, and the rhythm of the planet itself. At this stage, the distinction between seasons disappears. There is no summer. There is no winter. There is only cold, persistent, unchanging. The equator, once Earth's final refuge, fails to resist the global freeze. Solar radiation still reaches the surface, but reflection dominates absorption. Ice returns most incoming energy back into space, leaving little behind. Surface temperatures stabilize far below freezing, not extreme in fluctuation, but extreme in permanence. The planet no longer oscillates, it settles. Oceans, once dynamic and restless, lose their defining property: motion. Layer by layer, liquid water disappears. Ice thickens downward, compressing trapped heat until circulation slows to insignificance. Without moving oceans, Earth loses its primary climate regulator. Heat can no longer be redistributed. The planet fragments thermally into isolated zones of cold, none of them warm enough to restore balance. The atmosphere thins perceptually, not in mass, but in activity. Water vapor vanishes. Clouds cease to form. The sky becomes permanently clear, sharp, and dry. Precipitation ends entirely. There is no rain, no snow, no cycling of water. The hydrological system collapses, not violently, but absolutely. Carbon dioxide levels drop to minimal values. Chemical weathering stops. Biological exchange ends. What little gas remains becomes locked beneath ice or frozen into solid compounds. The greenhouse effect fails completely. Earth no longer retains heat. It radiates energy freely into space, becoming thermally aligned with its cosmic surroundings. Life on the surface reaches its physical boundary. Photosynthesis becomes impossible. Light exists, but without usable energy. Plant tissue freezes, cellular processes halt. Growth ends. Animals disappear from the surface record, not all at once, but inevitably. Food webs collapse sequentially, from the base upward, until no structure remains. Human survival becomes unsustainable. Technology relies on flow of energy, of materials, of maintenance. All of these fail. Power generation stops. Fuel solidifies. Shelters cool faster than they can be heated. Civilization does not fall dramatically. It freezes, leaving behind silent frameworks. Cities encased in ice, preserved but unusable. Only beneath the surface does activity persist. Deep underground, geothermal heat remains stable. Rock insulates. Pressure preserves liquid environments. Microbial life continues within fractures, within porous stone, within isolated pockets of warmth. Life compresses into minimal forms, slowing, simplifying, enduring. From orbit, Earth becomes a different planet, a sphere of high reflectivity, almost entirely white. Oceans indistinguishable from land. Clouds absent. Movement minimal. The planet reflects nearly all sunlight. It absorbs little. It radiates efficiently. Its temperature stabilizes at a new equilibrium. Cold, but stable. This is not a temporary crisis. It is a locked state, a snowball Earth, sustained, self-reinforcing, and resistant to change. Time stretches differently now. Thousands of years pass without visible alteration. Millions with only subtle internal evolution. The planet waits, not consciously, but physically, for conditions to change. Earth has not died. It has entered suspension. A system paused, silent, complete, and frozen. Time begins to move differently on a frozen Earth. Days still pass, nights still fall, but nothing responds to them anymore. Once the planet is fully locked in ice, change does not stop. It slows beyond notice. The surface settles into permanence. Ice sheets no longer advance rapidly, not because the cold weakens, but because the world is already covered. Continents lie buried beneath immense pressure. Mountains lose their sharpness. Valleys disappear. The landscape becomes smooth, flattened by weight and time. The oceans, once in constant motion, are now silent beneath thick ice. No waves disturb the surface. No currents move heat across the planet. Without circulation, the oceans no longer regulate temperature. They become vast, motionless reservoirs of cold. Above the ice, the atmosphere enters a state of calm inactivity. Evaporation stops. Clouds no longer form. Precipitation becomes impossible. The sky remains permanently clear, dry, sharp. Heat escapes freely into space, with nothing to slow its loss. Daylight still reaches the surface, but it brings little energy. Night follows, and the cold deepens again. The daily cycle loses its influence. Wind continues to exist, but it carries no moisture. It moves fine dust and ice grains across the surface, slowly reshaping frozen plains, millimeter by millimeter. Human structures remain where they were left. Cities are preserved beneath ice. Buildings stand frozen in place. Metal grows brittle. Concrete cracks gradually. Nothing collapses suddenly. Everything degrades quietly, without witnesses. The soundscape of Earth disappears. There are no storms, no rain, no thunder, only silence, interrupted occasionally by deep fractures within the ice. From orbit, Earth appears stable and unchanged, a bright, reflective sphere, cold, symmetrical, almost artificial in its stillness. Yet beneath the frozen surface, time continues its work. Chemical reactions slow, but do not end. Heat rises slowly from the planet's interior, barely noticeable, yet persistent. Deep underground, liquid water remains trapped, protected by pressure, insulated by rock. In these isolated environments, microbial life survives, not expanding, not evolving rapidly, simply enduring. These organisms do not sense the frozen world above. Their existence follows chemical rhythms, not sunlight. On the surface, nothing signals recovery. No melting begins. No collapse accelerates. The frozen Earth becomes stable. A planet no longer shaped by life, but by physics alone. While the surface of Earth remains locked beneath vast sheets of ice, the planet itself has not become inert. Beneath the frozen shell, processes that began billions of years ago continue, slowly and steadily, unaffected by the silence above. The interior of Earth remains warm. This heat does not come from the sun, nor does it depend on the atmosphere or the oceans. It is generated deep within the planet by the slow decay of radioactive elements and the residual energy left from Earth's formation. This geothermal heat moves upward at an almost imperceptible pace, traveling through layers of rock that act as insulation. When the surface freezes, this insulation becomes even more effective. Ice traps heat far more efficiently than open land or liquid water, preventing the planet from losing all internal warmth. As a result, the frozen Earth is not uniform. Beneath kilometers of ice, temperatures gradually rise with depth. In certain regions, especially beneath former oceans and tectonic boundaries, this heat is sufficient to maintain liquid water. These hidden environments exist entirely cut off from the surface. They do not receive sunlight. They do not exchange gases with the atmosphere. They do not participate in any global climate system. Yet they remain stable. Subglacial lakes form where pressure lowers the freezing point of water. These lakes are dark, isolated, and ancient. Some may persist for tens of thousands or even millions of years without ever interacting with the world above. Within these environments, life does not disappear. It simplifies. Complex organisms cannot survive here. Plants are impossible without light. Animals cannot persist without food chains. But microorganisms adapt. These microscopic forms of life rely not on photosynthesis, but on chemical reactions. They extract energy from minerals, from interactions between rock and water, from slow geochemical processes that continue regardless of surface conditions. Life becomes minimal, efficient, and extremely slow. Time behaves differently in these depths. Biological processes that once occurred over hours or days now unfold over years or centuries. Reproduction is rare, mutation rates are low, evolution slows to a crawl. Above this hidden biosphere, the surface remains unchanged. Ice sheets do not melt. Atmospheric circulation does not return. There is no communication between the two worlds. The frozen shell becomes a permanent barrier, dividing Earth vertically into layers of experience. A silent surface and a persistent interior. Geological activity continues beneath the ice. Tectonic plates still move, though their motion is slowed by the immense pressure above. Volcanoes remain active in certain regions, but eruptions are often suppressed or contained by ice. When volcanic activity does break through, its effects are local and temporary. Small pockets of ice melt, steam is released, water briefly flows. But these moments do not change the planet's global condition. They fade quickly, absorbed by the surrounding cold. Earth's core continues to rotate. The magnetic field remains active. Charged particles from space are still deflected. Auroras may still form near the poles, faint and unseen, dancing above a world with no observers. Structurally, the planet is alive. Dynamically, it is constrained. The systems that once interacted freely are now isolated from one another. The surface no longer influences the interior. The interior no longer reshapes the surface. This separation defines the frozen Earth. Over immense spans of time, this internal persistence becomes the planet's only form of continuity. Not growth, not recovery, but endurance. Earth no longer evolves rapidly. It does not adapt. It does not respond. It waits. Not consciously, but physically, held in a stable configuration that resists change. Only a significant external shift could disrupt this balance. A stronger sun, a dramatic increase in greenhouse gases, a catastrophic impact. Until then, the frozen Earth remains suspended between activity and stillness, a planet whose surface has ended, but whose interior quietly continues.
Time continues to pass on the frozen Earth, but it no longer brings change. Years accumulate quietly. Centuries layer themselves over the ice. Millennia leave no visible trace. The surface of the planet remains exactly as it was. White, still, unresponsive. The frozen state becomes normal. Without oceans in motion and without an active atmosphere, Earth loses its short-term memory. There are no storms to reshape the land, no seasons to introduce variation, no cycles to disturb the equilibrium. The planet settles into a long-term condition of stability. This stability is not balance, it is stagnation. The ice sheets grow older, not thicker, but denser. Compressed by their own weight, they trap ancient air, dust, and chemical signatures, locking entire eras beneath the surface. These layers become a timeline, preserved perfectly, because nothing erases them. On the surface, radiation from the sun continues to arrive, but almost all of it is reflected away. The planet absorbs very little energy. Its temperature fluctuates only slightly, locked within a narrow, frozen range. Day and night still alternate, but they no longer matter. The atmosphere remains clear and dry. With no water vapor, there is no insulation. Heat escapes easily, preventing any gradual warming. The frozen Earth reinforces its own condition. Human presence leaves no new marks. Cities remain entombed. Satellites decay slowly in orbit, eventually falling silent and disappearing beneath ice. Nothing new is built. Nothing is repaired. Nothing spreads. Biological activity remains confined to the deep subsurface. There, life continues at the edge of possibility. Microorganisms persist in isolated pockets of warmth, feeding on chemical gradients, moving energy slowly through minimal systems. These organisms do not expand. They do not transform the planet. They merely survive. Evolution continues, but at an almost imperceptible rate. Changes that once took generations now require geological time. Life waits. Geological processes also slow. Plate movement continues, but without surface feedback, its effects remain buried. Volcanic activity releases heat occasionally, but never enough to overcome the planet-wide freeze. Each disturbance is absorbed, neutralized, forgotten. The frozen Earth becomes predictable, not day to day, but century to century. There are no tipping points left to cross, no feedback loops left to activate. The planet has reached a stable configuration. This state can last indefinitely. Millions of years may pass with no visible change to the surface. The Earth becomes less a dynamic world and more a preserved object. From a cosmic perspective, it is still a planet, still orbiting its star, still interacting with space. But internally, its story has slowed to a near stop. The frozen Earth does not signal distress. It does not collapse. It does not recover. It simply continues, unchanged, awaiting an external force powerful enough to interrupt the silence.
For millions of years, the frozen Earth remains unchanged. Ice dominates the surface. Silence defines the atmosphere. Stability locks the planet in place. But no state in the universe is truly permanent. Even the most stable systems exist within larger forces, forces that operate on scales far beyond human time. The frozen Earth is no exception. Change, if it comes, will not begin on the surface. It will begin elsewhere. The primary driver of Earth's climate has always been the sun. Though it appears constant, the sun is not static. Over long periods of time, its energy output slowly increases. This process is gradual, almost impossible to notice within a single lifetime, yet powerful over millions of years. As solar radiation strengthens, slightly more energy reaches Earth. At first, this change has no visible effect. The ice reflects nearly everything. But energy accumulates, not on the surface, but within the system. Small imbalances begin to form. At the same time, Earth's interior continues its slow work. Volcanic activity never truly stops. Even beneath kilometers of ice, gases are released.
carbon dioxide, methane, water vapor. Most of these gases freeze or dissolve immediately, but not all. Over immense spans of time, small amounts accumulate. The frozen Earth does not respond quickly, but it does respond eventually. The atmosphere begins to change, almost invisibly. Greenhouse gases increase by tiny fractions, not enough to cause melting, not enough to raise surface temperatures. Yet. Then, in certain regions, local warming begins. Volcanic zones beneath thick ice create isolated pockets of liquid water. These regions are rare, small, short-lived, but they matter. Dark surfaces appear briefly. Rock, liquid water, bare ground. Unlike ice, these surfaces absorb sunlight. They do not reflect it away. They hold energy. This is where feedback begins. Small areas warm slightly more, slightly faster. The ice around them weakens. Cracks form. Melting accelerates locally. Still, the planet as a whole remains frozen, but the symmetry is broken. The frozen Earth is no longer perfect. As greenhouse gases continue to accumulate, the atmosphere slowly regains its insulating ability. Heat lost to space becomes less efficient. Nights grow marginally less cold. Days retain a trace of warmth. The change is subtle, but cumulative. Ice begins to thin in the most vulnerable regions first, near the equator, near volcanic hotspots, near ancient fault lines. Melting is not global. It is scattered. Liquid water appears intermittently, briefly, unreliably. It flows for short distances before freezing again. But water in motion returns something the frozen Earth has lacked for ages: change. As ice retreats in small zones, more dark surfaces are exposed. Absorption increases. The balance begins to shift. What was once a self-reinforcing freeze slowly becomes unstable. The planet approaches a threshold, not a sudden tipping point, but a gradual transition. Ice no longer dominates every interaction. Energy begins to circulate again. Clouds form for the first time in millions of years. Thin, sparse, transient, but they exist. With clouds comes precipitation. Snow at first, then in rare moments, rain. The frozen Earth enters a fragile phase, neither fully frozen nor truly warm. A world between states. This phase is dangerous. Rapid melting could destabilize the crust, release trapped gases too quickly, trigger extreme feedback loops. But slow change offers a different path, a controlled return. Life beneath the surface senses this shift before the surface shows it clearly. Microbial ecosystems expand. Chemical gradients change. Energy becomes slightly more available. Life prepares, not consciously, but biologically. The frozen Earth is no longer waiting. It is transitioning. Still cold, still hostile, but no longer static. What follows next will determine whether Earth remains trapped in ice or begins the long journey back toward a living world.
The transition away from a frozen Earth does not arrive suddenly. There is no single moment of release, no dramatic collapse of ice. Instead, change spreads quietly, unevenly, almost cautiously. As greenhouse gases continue to accumulate, the atmosphere begins to behave differently. It does not grow thick. It does not trap heat aggressively, but it starts to slow the loss. Each night, a little more warmth remains. Each day, a little less energy escapes. The ice responds first in the most fragile places, near the equator where sunlight is strongest, along ancient fault lines where heat from below is closer to the surface, around volcanic regions where eruptions have weakened the frozen shell. Melting does not occur evenly. It appears in patches, isolated zones of slush and liquid water surrounded by vast fields of ice. These regions expand slowly, then contract, then expand again. For the first time in millions of years, water begins to move across the surface. Brief streams form. Shallow flows carve narrow paths. Most freeze again within hours, but some persist longer. Movement returns something essential: transport. Energy begins to shift from one place to another. Heat no longer remains trapped where it arrives. It spreads. Dark surfaces reappear. Bare rock, wet soil, liquid water. Unlike ice, these surfaces absorb sunlight. They store energy. They warm faster. This creates contrast. Warm zones beside frozen plains, melting edges against solid ice. The planet begins to differentiate again. Clouds become more common. At first, they are thin and short-lived, but they matter. They trap heat at night. They redistribute energy during the day. Precipitation returns, slowly. Mostly snow, occasionally sleet, rarely rain. The hydrological cycle does not restart fully. It stutters, starts, stops, reorganizes. But its presence marks a fundamental change. Ice sheets thin from below as well as above. Geothermal heat weakens their foundations. Meltwater lubricates their base. Movement resumes. Slow at first, almost imperceptible, then measurable. Glaciers retreat, not rapidly, not dramatically, but consistently. They pull back from valleys, release pressure from the crust. The land begins to rise. This rebound reshapes the surface. New fractures appear. New pathways for water form. The landscape becomes active again. As ice retreats, gases trapped for millions of years are released. Carbon dioxide enters the atmosphere. Methane escapes from ancient sediments. This reinforces the warming. The feedback has reversed. What once strengthened the freeze now strengthens the thaw. Life responds cautiously. Microbial ecosystems expand upward from the depths. They colonize meltwater, thin soils, exposed rock. Life does not explode. It spreads carefully, testing the surface. The planet enters an unstable phase. Too much warming could trigger floods. Too little could restore the freeze. Earth balances between extremes. But balance, even unstable balance, is movement. And movement
is recovery. The frozen Earth is no longer a static object. It is changing again. Slowly, unevenly, but undeniably. As melting continues, the Earth begins to resemble a planet once more. Not the world it used to be, but something new. The retreat of ice reveals vast stretches of raw land. Surfaces untouched for millions of years are exposed to air, water, and light. Rock fractures under temperature changes. Minerals dissolve slowly into meltwater. The foundations of soil begin to form. Water becomes the primary agent of change. Streams carve shallow channels. Lakes gather in depressions left by retreating glaciers. Oceans, once sealed beneath ice, begin to reconnect, slowly restoring circulation. The atmosphere grows more complex. Clouds become thicker. Precipitation becomes more regular. Snow gives way to rain in limited regions. The hydrological cycle begins to function again, not smoothly, but sufficiently. With liquid water on the surface, chemistry accelerates. Carbon dioxide dissolves into oceans. Weathering resumes. The planet starts regulating itself once more. Life responds carefully. Microbial organisms spread across wet surfaces. They colonize shallow waters and mineral-rich soils. Photosynthesis returns, not through forests or plants, but through simple organisms. Oxygen begins to appear in trace amounts, not enough to alter the atmosphere quickly, but enough to signal a shift. Energy begins flowing through biological systems again. These early ecosystems are fragile. Temperature fluctuations remain extreme. Weather patterns are unstable. Floods and freezes alternate unpredictably. Life adapts by remaining simple. Over long periods of time, complexity increases slowly. Microbial mats thicken, soils deepen, chemical cycles strengthen. The planet regains resilience, not rapidly, but persistently. As oceans warm further, currents strengthen. Heat begins redistributing across latitudes. Equatorial regions stabilize first. Polar regions remain cold, but no longer absolute. Ice retreats toward the poles, not disappearing entirely, but becoming seasonal once again. The Earth rediscovers variation. Atmospheric composition continues to shift. Greenhouse gases decrease as biological processes absorb carbon. Cloud systems moderate temperature. The planet approaches a new balance. This balance is different from the past. Sea levels are altered, landforms reshaped, ecosystems reset, but it is stable. Life has returned, not because conditions were ideal, but because persistence allowed it. The Earth demonstrates its defining trait: adaptation. What emerges is not recovery, but transformation. A planet changed by ice, marked by its absence, and reshaped by time. The frozen era leaves scars, but also structure. New coastlines, new climates, new possibilities. The Earth moves forward, not to what it was, but to what it can become. After the ice retreats and the climate stabilizes, the Earth enters a phase it has never experienced before. Not recovery, not rebirth, but redefinition. The planet is no longer frozen, yet it is not warm in the way it once was. Its temperature settles into a narrow range, cooler than the ancient past, but stable enough to sustain surface activity. The oceans return, but they are different. Sea levels are altered permanently. Entire continental shelves lie exposed. New coastlines stretch across the planet, reshaping geography on a global scale. Ocean circulation resumes, but along unfamiliar pathways. Currents flow slower. Heat transport is uneven. Some regions remain cold indefinitely, while others stabilize into mild, temperate zones. The atmosphere finds a new balance. Greenhouse gases decrease gradually, absorbed by oceans and early ecosystems. Cloud systems become more organized. Storms return, but weaker, less frequent, and more localized. The hydrological cycle is functional again, yet unpredictable. Rain falls in regions that were once deserts. Other areas remain dry for centuries. The planet no longer follows its old patterns. The land continues to rise in former ice-covered regions. Isostatic rebound reshapes continents slowly. Mountains lift. Valleys widen. Earthquakes occur as the crust adjusts to lost pressure. This geological activity does not signal instability. It signals adaptation. The planet is redistributing weight, seeking equilibrium. Life responds carefully to this new world. Complex ecosystems do not appear immediately. The surface is chemically young, soils are thin, nutrients are unevenly distributed. Biological expansion occurs in stages. Microbial communities dominate vast areas. Simple plants appear near water sources. Growth is slow, deliberate, and cautious. There are no forests yet, no large animals, no complex food webs. The planet prioritizes stability over speed. The atmosphere continues to change subtly. Oxygen levels increase, not explosively, but steadily. This shift alters chemistry across the surface. New minerals form. New reactions become possible. Ultraviolet radiation remains high in some regions due to a thinner ozone layer. Life adapts by remaining close to water or by developing protective mechanisms. The Earth has entered a long middle age, no longer violent, no longer extreme, but unfamiliar. What existed before the freeze cannot return exactly as it was. Evolution must begin again from a different starting point. The planet now follows new rules. Climate systems are simpler. Feedback loops are fewer. Extreme swings are rare. Stability dominates. From space, Earth appears calm. Blue oceans, white polar caps, broad landmasses shaped by ice and time. But beneath this calm surface, a new story is beginning. Not a story of survival, but of adaptation to a changed world. A world shaped by cold and defined by restraint. The stabilized Earth does not rush forward. After surviving global ice and slow recovery, the planet enters a phase defined not by crisis, but by reconstruction. This reconstruction is not guided by intention. It follows physical laws, chemical gradients, and biological opportunity. The world reorganizes itself. The oceans return to their role as planetary regulators, but they do so differently than before. Currents move more slowly. Temperature contrasts are reduced. Energy transport becomes gentler. Extreme events grow rare. Storm systems form less often. Large-scale climatic oscillations weaken. The planet becomes calmer and more predictable. This predictability allows long processes to continue uninterrupted. Weathering resumes across exposed continents. Rain interacts with newly revealed rock. Minerals dissolve and migrate. Soils begin to form. Slowly, methodically. Surface chemistry evolves. Carbon is drawn down from the atmosphere and stored in oceans and sediments. Oxygen continues its gradual rise. The air becomes less hostile, though balance remains fragile. The absence of complex life slows progress. There are no forests to regulate moisture, no deep roots to stabilize soil, no large animals to redistribute nutrients. The planet depends entirely on microbial and simple plant activity. These early ecosystems expand cautiously. They follow water. They follow light. They avoid extremes. Growth concentrates along coastlines, river systems, and stable plateaus. Vast interior regions remain largely empty. The continents appear unfinished. Bare rock dominates wide areas. Soils are shallow. Erosion occurs easily. Rivers shift their courses often. Floodplains change shape. The landscape remains flexible. Geological processes continue. As ice weight disappears completely, the crust rebounds unevenly. Some regions rise faster than others. This imbalance produces earthquakes, not violent, but persistent. Fault lines adjust. New fractures open. The planet releases long-held tension. Volcanic activity becomes more visible. Without ice suppressing eruptions, gases enter the atmosphere directly. This does not destabilize climate globally, but it introduces local variation, temporary warming, localized cooling, chemical diversity. Earth's magnetic field remains strong. Radiation from space is deflected efficiently, allowing surface chemistry to proceed safely. However, the ozone layer remains thin. Ultraviolet radiation penetrates deeper than in the ancient past. Life adapts by remaining close to water or beneath protective layers. The planet becomes selective. Only organisms tolerant of variability survive. Evolution favors resilience, not speed. Time stretches. Thousands of years pass with only incremental change. New species emerge slowly. Extinctions remain rare. The planet remembers instability. Global feedback loops are fewer. Ice no longer dominates reflectivity. Vegetation is still limited. Energy balance stabilizes through simpler systems. This reduces the risk of another runaway freeze or extreme warming. Earth becomes conservative. It resists dramatic shifts. This restraint is the legacy of ice. From orbit, the planet appears restrained. Blue oceans, muted greens, wide expanses of exposed land. Quiet, but active. Every system functions, just slower and with less excess. The Earth has learned efficiency, not through intention, but through experience. This phase may last millions of years, an era of gradual development. No sudden revolutions, no explosive growth, only accumulation, layer by layer. The planet is no longer fragile, but it remains cautious. Its future will be shaped not by dramatic events, but by persistence. As the new Earth settles into its long era of stability, the planet begins to reveal a subtle pattern, not of rapid growth, but of careful progression. The systems that now govern Earth operate with restraint. They no longer amplify change aggressively. They moderate it. Climate responds slowly. Ecosystems expand cautiously. Geological processes unfold without urgency. The planet has learned the cost of extremes. Over extended periods of time, regional climates begin to differentiate more clearly. Some zones stabilize into cool, temperate environments. Others remain cold and dry for thousands of years. A few regions, influenced by ocean currents and latitude, develop mild and predictable conditions. These zones become centers of biological activity. Life spreads unevenly, not in sweeping waves, but in narrow corridors, along coastlines, along river systems, around shallow seas and stable lakes. Interior regions remain largely untouched, too dry, too cold, or too geologically unstable. This uneven distribution shapes the planet's future. Evolution proceeds locally. Species adapt to specific niches. Global dominance does not emerge. The planet favors diversity over expansion. As ecosystems mature, they begin to influence the environment more noticeably. Microbial mats alter surface chemistry. Early plant-like organisms stabilize soils. Atmospheric gases shift gradually. These changes are subtle, but cumulative. Oxygen continues its slow increase, not enough to support complex animal life, yet, but sufficient to alter oxidation processes across the surface. Rocks weather differently. Minerals form new compounds. The planet's chemistry becomes more dynamic. Oceans play a central role in this phase. Their slower circulation creates long-lasting temperature zones. Cold currents persist. Warm currents are weak but stable. Marine environments diversify. Life in the oceans evolves earlier and faster than on land. Shallow seas become laboratories of adaptation. Here, energy is more available. Chemistry is active. Protection from radiation is greater. Simple multicellular organisms may appear. Fragile, short-lived, but significant. On land, progress remains slower. Soils deepen gradually. Weather patterns remain gentle. Extreme events are rare. This allows fragile life forms to persist long enough to adapt. The planet now operates under long feedback loops. Changes introduced today may take tens of thousands of years to express their full effect. This slows both recovery and collapse. Earth becomes resistant to sudden transformation. Geological quiet does not mean inactivity. Mountain ranges continue to rise slowly. Plates adjust. Basins deepen. But these changes occur beneath functioning ecosystems, not in their absence. The surface and interior are reconnected, but balanced. The memory of ice remains encoded in the planet, in its topography, in its chemistry, in its restrained behavior. Earth no longer seeks rapid equilibrium. It tolerates imbalance as long as it remains bounded. From a planetary perspective, this era represents maturity, not youth, not decline, but a controlled, adaptive middle state. If observed from space, the planet would appear calm and unremarkable. No dramatic storms, no global transformations. Yet within this calm, countless slow processes unfold. Life does not race toward complexity. It experiments. It fails quietly. It succeeds incrementally. The planet allows this because it no longer punishes small mistakes with global catastrophe. This Earth is not fragile, but it is not aggressive. It does not dominate its star system. It does not reshape itself rapidly. It persists. Over millions of years, this persistence may allow the return of complexity, or it may favor simplicity indefinitely. The outcome is not predetermined. What is certain is that the planet now follows a slower rhythm, a rhythm shaped by cold memory and tempered by restraint. The Earth continues forward, not driven by urgency, but guided by endurance. As millions of years pass on the stabilized Earth, a quiet transformation begins to unfold. Not in the climate, not in the oceans, but within life itself. The planet has provided stability. Time has provided opportunity. Now, complexity begins to emerge. In shallow seas and coastal waters, life experiments with new forms of organization. Single-celled organisms cooperate, they cluster, they specialize. These changes are not dramatic, but they are irreversible. Energy flow increases. Photosynthetic organisms become more efficient. They capture sunlight more reliably. They release more oxygen into the atmosphere. This oxygen does not accumulate rapidly. It reacts, it binds, it alters chemistry. Over long periods, the atmosphere changes composition. Oxygen levels rise gradually. Greenhouse gases decline. The sky becomes clearer, but chemically richer. This shift affects every surface process. Oceans respond first. New ecological layers form. Surface waters differ from depths. Nutrients circulate more effectively. Marine ecosystems diversify. Food chains lengthen. The appearance of simple multicellular life marks a turning point. These organisms are fragile. They require stable conditions. They cannot tolerate extremes. Their survival confirms that the planet has entered a safer phase. On land, progress remains slower. Soils deepen through biological activity. Microbial life stabilizes surfaces. Early plant-like organisms anchor themselves to rock. They do not spread quickly. They claim territory carefully. With life covering more surface area, feedback loops grow stronger. Vegetation reduces erosion. It moderates local temperatures. It influences rainfall patterns. The planet begins to respond to life, not just host it. This marks a critical transition. For the first time since the freeze, biology becomes a geological force again. Climate regulation improves. Carbon is drawn from the atmosphere more efficiently. stored in biomass, buried in sediments. Temperature fluctuations decrease further. Stability reinforces itself. Life adapts to the planet's cautious rhythm. Growth rates remain modest. Reproduction is slow. Extinction events are rare. Evolution favors endurance over speed. As ecosystems mature, new niches appear. Predation emerges in simple forms. Competition shapes behavior. Diversity increases, not explosively, but persistently. The oceans reach a new equilibrium. Circulation patterns strengthen slightly. Heat transport becomes more effective. Polar regions remain cold, but no longer isolated. Seasonality returns in limited form. Temperature varies gently. Light cycles influence behavior. The planet rediscovers rhythm without chaos. Geological processes continue to support this phase. Volcanic activity supplies nutrients. Tectonic motion creates new habitats. Mountain building influences rainfall. The planet and life co-evolve. From space, the Earth now appears subtly alive. Not lush, not vibrant, but active. Shades of muted green trace coastlines. Oceans show signs of biological productivity. Atmospheric composition stabilizes further. The scars of ice remain visible. High albedo regions persist near the poles. Altered coastlines remind of past extremes, but these scars no longer dominate behavior. The planet has entered a collaborative phase. Life shapes the environment. The environment constrains life. Neither dominates. This balance allows complexity to grow slowly, securely, without threatening collapse. The Earth is no longer recovering. It is developing. What emerges next will depend not on survival, but on interaction, on networks, on relationships, on systems within systems. The long shadow of ice fades, but its lesson remains. Change must be gradual. Growth must be measured. The planet moves forward, guided by patience and shaped by life. As biological complexity increases, the Earth enters a phase defined by interaction rather than expansion. Life no longer exists as isolated patches. Connections begin to form between land and sea, between atmosphere and surface, between organisms themselves. The planet becomes a network. In the oceans, ecosystems grow vertically as well as horizontally. Surface waters host photosynthetic life. Below them, layers of organisms feed on drifting material. Deeper still, slow-moving communities recycle nutrients. Energy flows downward, then back upward. This circulation stabilizes marine environments. Food webs lengthen. Simple predators appear, not aggressive, but efficient. They regulate populations, preventing uncontrolled growth. Balance emerges not through abundance, but through limitation. On land, biological influence becomes more visible. Early plant-like organisms spread across damp regions. They bind soil. They slow erosion. They trap moisture. This changes local climates. Temperature fluctuations soften near living surfaces. Humidity increases slightly. Rainfall becomes more predictable. Life begins shaping weather on a small scale. These localized changes accumulate over time. As vegetation expands, carbon storage increases. Atmospheric composition responds. Oxygen levels continue their gradual rise. Carbon dioxide declines further. The greenhouse effect weakens slightly, but not dangerously. Climate regulation improves. The planet becomes more forgiving. Extreme swings are rare. Feedback loops dampen rather than amplify change. The Earth favors moderation. Geological processes adjust to biological presence. Roots fracture rock. Organic acids accelerate weathering. Sediments accumulate differently. The land transforms, not by force, but by persistence. Rivers stabilize their courses. With vegetation anchoring banks, flooding becomes less destructive. Sediment transport slows. Deltas form gradually. Coastlines become more complex. This complexity creates opportunity. New habitats emerge. Wetlands, shallow lakes, protected coastal zones. Life diversifies further. Evolution now operates within structured systems. Competition exists, but it is constrained. Predation limits dominance. Resource availability limits expansion. No single lineage overwhelms the rest. The planet encourages balance over conquest. In the atmosphere, circulation patterns become more coherent. Jet streams form weakly. Pressure systems stabilize. Weather becomes rhythmic, not dramatic, not violent, but persistent. Seasonal cycles strengthen slightly. Light and temperature vary gently through the year. Organisms adapt behaviorally. Growth aligns with cycles. Rest follows activity. The biosphere matures. Interactions multiply. Symbiosis becomes common. Mutual dependence replaces isolation. Life becomes interconnected. This interconnectedness increases resilience. Disturbances spread less far. Local disruptions remain local. The planet absorbs shock quietly. Over millions of years, these systems deepen. Soils thicken. Nutrient cycles tighten. Energy efficiency improves. The Earth becomes internally consistent. From space, the planet appears subtly transformed. Patterns emerge. Bands of biological activity. Stable cloud formations. Predictable seasonal shifts. The chaos of recovery fades. The memory of ice remains embedded, but it no longer governs behavior. Cold extremes retreat to the margins. The planet's core systems now operate independently of past trauma. Life and Earth have entered partnership. Neither dominates completely. Each constrains the other. This partnership defines the new era, a world where complexity grows, not explosively, but sustainably. The future is no longer fragile. It is cautious, but capable. As interconnected systems deepen, the Earth begins to exhibit characteristics of maturity. This maturity is not defined by abundance nor by rapid innovation, but by coordination. Processes that once operated independently now influence one another continuously. The planet behaves as a single, integrated system. Energy flow becomes increasingly efficient. Less energy is wasted. Less is lost to extremes. Sunlight is captured, distributed, and reused through layered biological and physical pathways. This efficiency limits excess and reduces instability. The oceans reach a steady operational state. Nutrient cycles tighten. Dead zones shrink. Biological productivity becomes evenly distributed. Large-scale collapses no longer occur. Instead, fluctuations remain local and short-lived. Marine ecosystems grow more complex. Food webs branch. Specialization increases. Organisms adapt not only to environments, but to one another. This interdependence limits rapid population explosions and prevents systemic failure. On land, surface life extends inward from coasts and waterways. Vegetation colonizes higher ground. Soils deepen further. Water retention improves. Deserts remain, but they are bounded. The hydrological cycle stabilizes. Rainfall patterns repeat predictably. Floods are absorbed by wetlands. Droughts resolve slowly. The planet buffers extremes rather than amplifying them. Atmospheric chemistry continues to evolve. Oxygen levels approach a functional plateau, enough to support energetic metabolism, but not enough to destabilize climate. Greenhouse gases remain regulated through biological uptake and geological storage. This regulation creates a resilient equilibrium. Temperature ranges narrow further. Polar ice persists but no longer dominates reflectivity. The planet resists runaway cooling and runaway warming alike. Seasonal rhythms strengthen, not harshly, but consistently. Life synchronizes with these cycles. Reproduction aligns with resource availability. Dormancy aligns with scarcity. The biosphere learns timing. Evolution now proceeds under constraint. Rapid change is penalized. Gradual adaptation is rewarded. Lineages that integrate smoothly persist longer than those that specialize excessively. The planet favors versatility. Geological systems respond accordingly. Erosion slows as vegetation stabilizes surfaces. Sediment transport becomes predictable. Mountain ranges erode gradually, without catastrophic collapse. The surface becomes smoother, older, more settled. This stability does not eliminate change, it reshapes it. Transformation occurs through accumulation, not disruption. Layer by layer, cycle by cycle. From orbit, the Earth appears calm and coherent. Cloud systems follow repeatable paths. Ocean color reflects stable productivity. Land masses show gradual transitions rather than sharp boundaries. The planet emits fewer extremes. No massive storms dominate the surface. No prolonged freezes grip continents. No sudden heating events cascade globally. The Earth has learned moderation. Life now plays a regulatory role, not by intention, but by presence. Biological processes continuously adjust energy flow, chemical balance, and surface conditions. The biosphere acts as a stabilizing layer. This layer absorbs disturbances. Asteroid impacts below a threshold are mitigated. Volcanic eruptions are localized. Climate anomalies fade rather than spread. The planet dampens noise. Over millions of years, this behavior becomes entrenched. The Earth no longer oscillates wildly between states. It occupies a narrow corridor of habitability. This corridor is not idealized. It includes hardship, scarcity, limits, but it supports persistence. The frozen era has reshaped planetary behavior permanently. The Earth is no longer naive. It does not respond to change impulsively. It adjusts cautiously, incrementally, with memory encoded in structure. This is not a peak, nor an endpoint. It is a condition, a planet operating within learned boundaries. What comes next will not be driven by survival alone, but by interaction within these constraints. Complexity may continue to rise, or it may plateau. The outcome remains open. But the Earth now possesses the systems required to carry complexity forward without destroying itself. As the Earth settles into its mature state, the pace of visible change begins to slow once more. Not because the planet is failing, and not because its systems are weakening, but because equilibrium has been reached across nearly every scale. The Earth no longer seeks correction, it maintains. In this phase, planetary processes continue almost invisibly. Oceans circulate with quiet persistence. Atmospheric patterns repeat with subtle variation. Geological motion proceeds beneath layers of soil and life. Nothing demands attention. The surface becomes familiar, not to an observer, but to the planet itself. Feedback loops operate smoothly. Disturbances dissolve into background noise. Extreme events remain isolated and contained. The Earth has learned restraint. Life adapts to this restraint. Species no longer expand aggressively. Territories stabilize. Population sizes fluctuate within narrow limits. Growth becomes optional, not necessary for survival. Evolution does not stop, but it loses urgency. Changes occur through fine adjustment rather than innovation. Traits are refined rather than replaced. Complexity reorganizes instead of escalating. This phase is not dramatic. There are no turning points, no revolutions, no thresholds waiting to be crossed. The planet exists in continuation. Energy input from the sun remains steady. Energy output to space is balanced carefully. The climate holds its form. Variability is present, but predictable. The oceans play their quiet role. They absorb excess heat. They release it gradually. They buffer chemical shifts long before they reach the surface. Marine life reflects this calm. Migration patterns stabilize. Reproductive cycles align with long-term conditions. Extinction becomes rare. On land, landscapes age. Mountains erode slowly. Rivers widen and deepen their channels. Coastlines smooth over time. The surface becomes less sharp, more continuous. Soils deepen further. Organic matter accumulates. Nutrient cycles tighten. Life becomes more efficient, less wasteful. The atmosphere reflects this efficiency. Gas concentrations fluctuate minimally. Cloud systems follow established paths. Weather patterns repeat with familiarity. The sky no longer surprises the surface. At this stage, the Earth could persist indefinitely. Millions of years could pass with no fundamental transformation. The planet has entered a long plateau. This plateau is not static. It is dynamic, but bounded. All motion occurs within learned limits. The memory of past extremes remains embedded, in ice preserved at the poles, in altered coastlines, in subdued feedback systems. The planet remembers, even when it no longer reacts strongly. This memory shapes behavior. When disruptions occur, systems respond conservatively. They absorb, redistribute, and settle. The Earth no longer amplifies shocks. From a cosmic perspective, the planet appears quiet. No bright signatures of instability, no extreme emissions, no violent transitions. just persistence. Life mirrors this persistence. Civilizations, if they exist, would find this world predictable. Resources renew slowly but reliably. Climates shift gradually. The environment rewards patience. This is not a world of urgency. It is a world of continuity. And continuity changes the meaning of time. Moments matter less. Trends matter more. The planet thinks in spans, not instants. In such a world, the concept of an ending becomes unclear. Processes fade rather than stop. Transitions blur. Nothing truly concludes. The Earth does not prepare for collapse, nor for ascension. It simply persists. This persistence is not passive. It is active restraint, a learned stillness. And it is within this stillness that the final phase will emerge. Not abruptly, but naturally. As the Earth remains within its long plateau of stability, time itself begins to feel different. Not slower, but wider. Moments lose their sharp edges. Events blend into patterns. The planet no longer records history in incidents, but in spans. Change does not announce itself anymore. It accumulates quietly, layer by layer, cycle by cycle. 1,000 years pass with barely noticeable difference. In this era, the Earth is no longer shaped by reaction. It is shaped by continuation. Processes persist because they work, not because they must adapt. The climate drifts gently within narrow limits. Warm periods extend slightly. Cool periods return softly. Nothing accelerates. Nothing collapses. The system corrects itself before extremes emerge. The oceans embody this rhythm. Their surface changes daily, but their deep structure remains constant. Currents flow along ancient paths. Temperature gradients remain shallow. Chemistry evolves incrementally. The sea becomes a memory keeper. Marine life reflects this continuity. Long-lived species dominate. Rapid reproduction becomes less advantageous. Survival favors patience, not speed. Ecosystems value balance over dominance. On land, the landscape continues its slow aging. Mountains erode grain by grain. Rivers widen imperceptibly. Soils thicken beyond immediate necessity. The surface smooths. This smoothing affects everything. Water flows more predictably. Floods spread gently. Droughts resolve gradually. The land stops resisting the climate and begins cooperating with it. The atmosphere settles into repetition. Weather patterns return season after season with only slight variation. Clouds follow familiar routes. Winds trace known paths. The sky becomes dependable. This dependability changes life's priorities. Organisms no longer race against uncertainty. They invest in efficiency. Metabolism slows. Lifespans extend. Growth becomes conservative. Evolution continues, but it now favors refinement. Traits are optimized. Redundancies are reduced. Innovation is rare, but stable when it occurs. The biosphere behaves like a finished structure, not rigid, but complete. Energy circulates smoothly. Waste is recycled effectively. Nothing accumulates excessively. In such a system, disturbances lose their power. A volcanic eruption alters a region, then fades. A meteor impact scars the surface, then integrates. No event reshapes the whole. The Earth has developed inertia, not resistance to change, but resistance to disruption. From afar, the planet seems almost timeless. It emits no urgent signals. It demands no attention. It simply exists, confident in its cycles. This confidence does not imply perfection. Limits remain, scarcity persists, variation still matters, but uncertainty no longer dominates. In this era, the concept of progress becomes ambiguous. There is no clear direction, only continuation with subtle adjustment. Life no longer pushes outward aggressively. It circulates inward, maintaining itself. Expansion yields to sustainability. The planet's systems are now synchronized. Geology, climate, and biology operate on compatible timescales. No system outruns the others. This synchronization is rare. It is not guaranteed. It is earned through long experience. The Earth does not prepare for transformation. It prepares for duration. Millions of years stretch ahead, quiet, ordered, stable. In this state, the difference between present and future blurs. Tomorrow resembles today. Centuries resemble decades. Time becomes a field, not a line. And within this field, the final transition will not arrive as an event, but as a soft shift in awareness. As the Earth continues within its quiet balance, there is nothing left to resolve. No direction to choose, no outcome to predict, only continuation. The planet no longer asks questions. It no longer searches for form. It exists, complete within its cycles. Oceans move as they always have. Winds follow familiar paths. Life breathes in steady rhythm. Nothing presses forward, nothing pulls away. Time stretches gently. Moments dissolve into one another. Past and future lose their distance. There is only now, extended. The Earth does not announce its presence. It does not demand attention. It simply remains. In this stillness, there is no urgency. No need to remember every detail. No need to hold on to the story. The processes continue, whether they are observed or not. And as the planet rests in its quiet order, you are not required to follow it further. The journey has slowed enough to let go. Thoughts no longer need direction. Images can fade. The weight of time becomes light. The Earth turns, as it always has, without effort. And just as the planet settles into its long calm, you are free to settle as well. There is nothing more to reach for, nothing left unfinished, only rest. The universe continues quietly, and you may do the same. Good night.